Previous lecture, we learned how computers use bits to represent numbers, images, videos, and audio. A bit can only be true or false, or it has only two values. Then how do we create new knowledge or perform computations using just these true or false values? That's the reason why we should study propositional logic. This is the outline of the lecture. We'll start with the introduction about what, why, and how um, we need to study or know about propositional logic. Then we'll learn some common logical operators and some important related terminologies that we should know. Now, let's just start it with the introduction about what, why, and how is it related to CS. So what is propositional logic? It deals with propositions. It's going to deal with propositions. Let's see the pen over here. Okay. And the logical relationships between them. What does it mean is we're going to start with a set of propositions like proposition 1, then proposition 2, then proposition n. So they are just like set of bits or set of sequence of bits from bit 1 up to bit number n. Then we also study on the relationships among these propositions. Okay? And how do we combine the input proposition in order to create a new is called compound propositions. And this new compound proposition is a new values, or it is called as a new knowledge. So next one, you may have a question. So what does it mean is our proposition? This one is we already said quickly. A proposition is a statement that is either true or false. So it's similar to one bit. So one bit can only be on or off. So it can only be true or false. Okay? So the examples are proposition includes of like 1 plus 1 equals to 2. And this one is a true proposition. Okay? Another proposition is 1 plus 1 equals to 4. And this one is one proposition statement. And it is a false statement, but it is one proposition, even though it's false. The next one is a statement, say something like go out. And this one is not a proposition, okay, because it's just a statement. We cannot say it's true or false over there. Okay, another one is red color is beautiful. So this one is not a proposition because the red color may be beautiful for some people, but it may not be beautiful for some others. So it cannot be definitely true or definitely false. The next kind is the relationship that we'll see is to manipulate the bit sequence or manipulate the propositions in order to create a new compound proposition or create a new knowledge that we have seen. So the logical operators are used to manipulate propositions as we have seen. And why do we need to manipulate them? Because we want to create a new knowledge, as we'll see over here, in terms of a new proposition, because we're going to create a new bit for the computer. So there are many of them, but the main one including the not operator, then the and operators, and the or operators, the exclusive or operators, the conditional operators, and the biconditional operators. And in this lecture, we won't cover all of them later on. So this is a summary of the point that we covered so far, if you would like to read them in one slide. Now, next one is why do we study propositional logics? As one of the important point is that computer work with bits, and the propositional statement is only true or false, so it represents one bit. So It provides a formal system for externalized reasons about truth values and logical relationship between statements. This is very important. Also, it's also forms some foundation understanding for more complex logical system. And also, it is essential for constructing valid arguments and proving theorems and so. Then, how propositional logic is related to CS, as we already explained. So it's essential in designing algorithms and programming languages, and especially how computers work. Then also very much important is in circuit design, so that you understand that the computer are composed of many circuits to solve computation problems, and that's why. And also it forms the basis for Boolean algebra, and this one is being used a lot in computer science, let's say for digital logic and also for computer architectures, and also you want to use for database management systems as well. So in the next lecture, we're going to study about the next part of the lecture. We'll study about the common logic operation, or how do we manipulate the propositional statements.